So everyone can see this. I got one note open here. Okay. All right, so in section 1.5, I'm going to kind of jump around in it because probably most of this is pretty familiar. So it's 1.5 is on solving equations. So in other words, we have some algebraic expression, which I discussed in my last video. We have some algebraic expression, and then we set it equal to 0 or set it equal to some number, and that gives us an equation. So we'll primarily be looking at linear equations and quadratic equations, although sometimes higher equations involving maybe square roots will come up. So the first type of equation that you might encounter is a linear equation, and these are pretty easy to solve, but I'll just mention it anyways. So a linear equation is something of the form ax plus b equals 0, where a and b are real numbers. And to solve this, it's pretty straight. I mean, you're going to be given specific examples of linear equations, but you can really just solve the general linear equation very easily. So you would just subtract b from both sides. That will give you that. So, and then I guess you have a subcase. If a is not 0, then you can divide both sides by a. And that will give you negative b over a. And that's the solution to this equation. And of course, you have this other case. If a is 0, then there's not really much to do. So you have these two subcases. You have this case where a is not 0, in which case you can divide by a to get this as your solution. Or a is 0, in which case there's not really much to do. If a is 0, then ax is 0, and then that forces b to be 0, so everything is 0. So actually under this case, in fact, you can say every real number x is a solution. Right, because if a is 0, then whatever x is, a times x will also be 0, and if b also has to be 0, then the equation will be satisfied. So you have when a is 0, when this coefficient is 0, every real number is a solution to the equation. But if a is not 0, then you have just one solution, this one right here. That's really all I want to say about linear equations. Maybe I'll just go through one example. Actually, I will go through this one example. So this is example 1 in the book. So the example is 7x minus 4 plus equals 3x plus 8. So you can go through this procedure right here by putting it in this form, writing it as ax plus b equals 0, and then just saying this has to be the solution, assuming your coefficient's not 0. But it's easier just to go through this procedure that I went through right here in this case right here. Just do the manipulation. It's just easier to do that. So the idea is to get on one side we want to isolate x on one side, and then all the constant terms on the other side. So we'll bring this 3 over to the other side by subtracting by 3x. So if we subtract by 3x, we get 4x minus 4 equals 8. And then we want to put this 4 on the other side by adding 4 to both sides of the equation. That will give us 4x equals 12 and then we can divide by 4 to get x is equal to 3. So any questions on that, or is that pretty straightforward? Okay, so let's move on then. So the next type of equation we can work on, so for linear equations, there's really only one method to solving them. You just isolate x on one side, put the constant terms on the other side, and you're pretty much done. For quadratic equations, there can be a few cases depending on the nature of the quadratic equation. So let's look at this a little more closely. So a quadratic equation is an equation of the following form. So it's ax squared plus bx plus c equals 0. And then a, b, and c are all real numbers. And depending upon, as I said, with the nature of the quadratic equation, maybe you might either do one of a few things. You might be able to just factor the equation, or you might have to complete the square / use the quadratic formula. So for factoring, when we do factoring, we have to use the following fact, which is probably obvious to everyone, but I'll just point it out. It says that if you have a product of two numbers equals 0, that happens if and only if one of the two factors is 0. So this has to do basically with the fact that, and this is just nonsense to you or mumbo jumbo, but if you're interested in this, more advanced mathematics, this has to do with the fact that R is a so-called integral domain. So when you get to more advanced mathematics, you're interested in more general number systems, not necessarily just the real numbers. And there's a whole class of these number systems that are so-called integral domains, and they have this property right here, this exact property that real numbers have, that if you take the product of two non-zero, or if you take the product of two numbers and it's 0, that happens if and only if one of the two factors is 0. And this follows from the fact that R is an integral domain. But if that's just an aside, if you're interested, it doesn't matter a whole lot. So this will be useful when we want to solve certain equations. We can use this fact to factor them. So let's look at example 4 in the book. So example 4 says that x squared plus 5x is equal to 24. And so we want to put it in this form right here. And that will actually help us see how to factor. We want to put it in this form. And I'll show us how to factor this. That'll reveal how to factor this quadratic. So if we do that, we get x squared plus 5x minus 24 equals 0. And if we remember, we did a video, or I did a video on factoring quadratics. The idea is that if you have a quadratic and you have this coefficient of 1 here, then it tells us immediately what we have to put in for these blanks. But then we need to worry about these two blanks. We need to find two numbers whose product is 24 and which sum to 5. So if you think about that a little bit, you can look at factors of 24. That's 1 and 24. That would be 2 and 12. and then what was it, 6 and, or 3 and 8, or 6 and 4, yeah, sorry. Was 3 and 8, and then 6 and 4, right? Yeah. I think that's right. But we have to worry about the sign too, because we have this negative here. But it's, if you go through these possibilities, you can rule out this one, and this one, and you'll see that the only possibility left is 3 times 8, and that gives you what you want. So we have to put a 3 in here and an 8 here, but we have to worry about the sign. So one of them has to be negative, one of them has to be positive to get negative 24. And because we have a positive coefficient in the middle term, that would tell us that we need the bigger number to have the positive. So we want this plus sign to be associated to this 8, and then the negative over here, and that will give us, if you FOIL this back out, you'll get this line right here, because negative 3 times 8 gives you the negative 24. But then when you take the sum of these two, you get the 5 back. You get positive 5. And then by this fact up here, this fact right here, we know we have a product of two numbers is equal to 0. So that implies that x minus 3 is 0, or x plus 8 is 0. And these will just actually be both of them are solutions. So these will be the solutions. So are there any questions on this? Anything I've said so far? I probably should have stopped sooner asking it. Is this all pretty clear? So for this one, I mean, you can always, I haven't introduced it yet, but you can always use the quadratic formula. You can always just use that, but sometimes that's a lot to keep track of. With the quadratic formula, you have to worry about all these coefficients here, right? Where'd it go? You have to worry about A, B, and C, and you have to remember the quadratic formula. But this is, the first thing you should always try is just to factor it. So you don't have to, use your memory to, go on your memory to figure out the quadratic formula. You can always just try this factorization. Just put everything on one side of the equation and ask yourself whether when you factor this constant term, do the factors work out so that you can factor it in this way right here. So you should always try factoring first. Okay, so if there's no questions, I guess we'll move on. All right. I got someone unmuted, so if you can mute yourself, I'd appreciate that. Unless you had a question, but yeah, all I heard was music, so. So another kind of I guess the book mentions this simple type of quadratic you can encounter is one of the form. The simple quadratic you can encounter sometimes is this. This sometimes you'll see people just say, "Oh, this is just done by," or the solution is just found by taking the square root of both sides. And that's technically this is a rule of thumb, but that's not really what's going on in the background. What's really going on in the background is you're factoring this. And then this is a consequence of factoring. So if you put the c on the one side, you can factor this. If you stare at this long enough, you'll see that this is a correct factorization of this equation right here. So you do, if you FOIL through, you get x squared, then you get x times x square root of c, and then over here you get negative square root of c times x, so that those middle terms will cancel out. And then when you multiply square root of c times square root of c, you just get c back, but there's that negative sign right here, which gives you the negative sign here. And then you just use the fact that I mentioned up here. You have this product of two numbers is 0, so that implies one of the two factors has to be 0. And in fact, both of them can be 0. That's entirely possible also. So that's why, you know, like the rule of thumb is you can just take the square root of both sides, but this is really what's going on in the background, is that you're doing this factorization. So as I said, this is going to be pretty short. So the last thing I want to talk about is completing the square. So it's not always the case that a quadratic equation can be factored immediately, but there's a way of manipulating the equation so that we can factor it. So the idea is, I guess I'll just illustrate this through example. This is probably the easiest way to do it. There's this more abstract approach of being more general, but I'll just go through an example. So the idea is that you can't factor this straight away. So 13 is a prime, so that means the only factors are 1 and 3 itself. And there's just no way that 1 and 13 can sum to -8. Whether, you know, even putting signs, exchanging signs on them. So like, well, the factors of, strictly speaking, the factors of 13 are, if you include negatives, it's -1 and -13, and then just 1 and 13. But neither of these sum to -8. So there's just no way to factor this. It's impossible. But the idea is to add something onto it so that you can factor it. And so the idea is, let me just write down the first step. The first step is to divide the middle term by 2. So you divide the middle term by 2 and add and subtract the result. So the middle term is squared, I should say. Add and subtract the middle result squared. You square it. So the middle term is -8. So I'm going to add in -8 divided by 2 squared, and then I'm going to subtract it off. So I'm not changing the equation, right? I've added something in, and then I'm subtracting it off. And then don't forget that you had this 13 over here. So now if this simplifies a little bit further, so this is this will be 4 squared. I'm sorry, yeah, 4 squared. And then this will be 4 squared also. Now this right here, this can be factored. This can be factored right here. It can be factored into x minus 4 squared. This -4 squared becomes 16, and then we have the 13 on the end. So is everyone good with these steps so far? So the only tricky part probably is this right here, just keeping track of this. So this, the middle term is right here, or the coefficient, I should say, the coefficient of the middle term. The coefficient of the x term, you divide it by 2, and you make sure you take the sign and everything. So you divide by 2 in square, and then you subtract it off, because you don't want to change the equation. And then so you add and subtract the same term. Then this next line I just simplified. I just simplified this piece right here. And then to go to the next line, I just factored this part and the square that's bracketed off right here. When you factor that, it's just x minus 4 squared. And then I can simplify this a little bit further. So if you add these together, you get negative 3 equals 0. And then I'm in that case where I have something squared. Well, let me just throw this on the other side, the 3. So if I add 3 to both sides, I get this. And now I'm in that situation where I have something squared equals 3. So I could just, take the square root of both sides. And then I add 4 to both sides, and this will be the solution. So does anyone have any questions on this, how I did this? So I didn't do factoring. You can't factor this, remember, because of this 13 right here. The factors of 13 are these. You got a question, someone?
Wait. Like, I'm kind of confused on what happened to 8x.
So right. Hold on. Lost my cursor. This one right here. This step.
Yeah.
Yeah. So let's just look at. So like this part's okay on the other side. I just have like a sum of some numbers. So let me see. So I have x squared minus 8x plus 4 squared. But 4 squared is just 16. But if you FOIL this out right here, so let's FOIL this out. So it's x minus 4 times x minus 4. So x times x gives you x squared, and then x times negative 4 gives you negative 4x, and then negative 4 times x gives you negative 4x, and then negative 4 times negative 4 gives you plus 16. And if you simplify this, you get x squared minus 8x plus 16. So these two things do equal, right? So x squared minus 8x plus 16 equals x minus 4 squared, right?
Yeah, so you just factor the first part of it. All right.
Yeah. So basically, let me just go through this again. So the idea is you look at the x term, you look at its coefficient, you divide by 2 and square it. So that's how I got this here. And you add that on, but I need to subtract it off. That's why I have to subtract off this term, because I don't want to change the equation. So I added and subtracted this term. Now, if you bracket it off like this, so if you bracket just these terms off, you can factor it as x minus 4 squared. But then you'll have these pieces over here still, right? You got to worry about these pieces right here. That's just some basic arithmetic, but these two things are equal right here, because just what we did down here, we kind of proved it by doing this right here. We FOILed it, and we just verified that these do in fact equal. So that's where that 8x went.
For equations like that and like anything, we can still use the quadratic formula if we prefer it though, right?
Yes. So if you're solving an equation, you can. The only thing though is that later on we're gonna look at equations of circles, and you need to put it on in so-called standard form, and that will require doing completing the square. So being somewhat familiar with this for just a couple things is good, but you can always go back on the quadratic formula, or at least to verify, you know, like if I did do completing the square correctly. In fact, this procedure right here, you use this procedure to prove the quadratic formula. The quadratic formula isn't just something you accept as true. Nothing in mathematics you accept as true. You have to prove everything. So the quadratic formula follows from this procedure of completing the square. I can show you guys. So let me go over that. Right. First, are there any questions about this example? Any other questions? No. Okay. So I'll prove the quadratic formula, and then so it's a little. Let me see. I don't think it's too long to prove. Yeah, it's a little messy, but it's not too bad. So you don't have to like follow every detail, but like just see that I'm using completing the square. So I just want to show you that the completing the square is used in the quadratic formula to prove the quadratic formula, I should say. So don't worry about all the calculations and details too much. So the idea is that so you start with something like this, and I want to just prove that the quadratic formula holds. So you're going to divide. So again, we're going to just assume that x or a is not 0. Because if a is 0, then we just have a line, right? And that's we already know how to deal with equations or linear equations. So we're going to assume a is not 0. So that means we can divide both sides by a. So here I'm going to give you a little taste of what more advanced mathematics is, proving these things. Some of these proofs are a little boring. This one's not like terribly fun, but I'm just trying to show how the quadratic formula or how the completing the square is used. But that's what more advanced mathematics is about, just proving things. Why are these theorems and ideas true, these facts true? So I'm going to just divide both sides by a. And then I'm going to take this term right here, I'm going to divide by 2 and then square it. Add and subtract that. So I'll have this. So I'm going to add and subtract this term right here. And then don't forget c over a. So if it just as in the other example, if you look at if you stare at these terms, I won't FOIL it just to verify, but if you look at this long enough, you stare at this long enough, you'll see that this piece right here I just underlined, it factors as this. So it's x plus b over 2a squared. And if you do the FOILing out on your own, you'll see that you do in fact get this back. And then I have this piece over here. Sorry, it should be c over a. Now, I'm going to put this piece on the other side of the equation. Or yeah, the other side of the equation. So I'll have b over 2a squared minus c over a. And then you can combine these to get, if you get or let me just do the common denominator actually. So this is 4a squared So if I can get a common denominator for this, I just multiply the top and bottom by 4a. So let me just do that right here. So I get 4ac over 4a squared. And then I can combine these. And you're probably starting to see the quadratic formula emerge already. So now I can do this trick where I take the square root of both sides, right? I'm allowed to do that now. So you get plus or minus square root of b squared minus 4ac over, so I took the square root of a fraction, so I just, the square root distributes over the numerator and denominator. If you take the square root of the denominator, that'll just become 2a, right? And then you just solve for x. And if you subtract b over 2a from both sides, they have, these two things have, so this has the same denominator as that, I can combine them. So I get negative b plus or minus square root of b squared minus 4ac over 2a. And there you have it. You have the quadratic formula. So this is why the quadratic formula is true from this completing the square procedure. So if you, the idea is if you remember completing the square, then you remember the quadratic formula. It follows from that method. Is there any questions about this? Like, don't get yourself hung up over the details too much. You know, there's a lot. I just wanted to go over this really quickly just to show you that the completing square is more fundamental than quadratic formula. But are there any, you know, just general questions about what I did here? All right, so I'm going to do just one more example of completing the square. Well, on a, you know, on with some actual numbers, just so we can get used to this, and then I think we'll just call it a day, or I'll leave it open to you for questions. So this is example 7 in the book. So you have 3x squared minus 5x minus 1 is equal to 0. So in the two examples I gave above, with the first example, we didn't have a coefficient other than 1. We had a coefficient of 1, I should say. I'm sorry. And when I went through the proof of the quadratic formula, I factored out, I divided both sides by the a, or I factored it out. So the first thing to do in this case, when you have a coefficient other than 1 on the x squared term, you want to factor that out. So you get 3x minus 5 over 3x minus 1/3. You can factor it out, you can divide both sides. I guess it doesn't matter a whole lot. And now I can do completing the square on this. It's the equation's set up to do that. So now I'm going to do the same thing. I'm going to take this middle term right here, the coefficient of the x term. I'm going to divide by 3 and square it, and then I'm going to add that in. So if I divide by 3, I get that squared, but then I have to subtract that off. So I get 5 over 2 times 3 squared, and then I subtract it off, and then I have this 1/3 over here. And I can simplify this a little bit. So I get 5 over 6 squared. And then this will be, this again, minus 5 over 6 squared. But let's just actually square that. We get 25 over 36 equal to 0. Actually, now I'm thinking about it. Maybe I should have just divided. I'm thinking of doing completing the square to find the equation of circles. Right here, I'm going to just add this step in. I'm just going to divide by 3. You won't always want to divide by 3, but if you're solving the equation, just divide that term actually. So if I divide by 3, I can get rid of the parentheses. So now we want to get so we have these two fractions right here. We want to get a common denominator so we can combine them. And if you just multiply this fraction right here, the numerator and the denominator by 12, you'll get a common denominator. Right? I think so. Always check my arithmetic because I'm really awful at arithmetic. So this term right here, we can factor this. And it's always going to be the case that this term is x minus the thing in the parenthesis. Or the s minus the thing in parentheses squared. So if you do that, you'll see that or if you FOIL this, you'll see that those two things actually equal each other. And then we can combine these two, and so you get, what do you get, 37 over 36, I guess. And then you can put this on the other side, the 37 over 6 on the other side. And I won't go through the rest of this, but the rest of it is you just take the square root and then you add 5 over 6 to both sides and simplify as much as you can. So this is, the rest of it I'll just leave to you, but I just wanted to go through these parts right here, completing the square. So does anyone have any questions about this completing the square right here?
What happened to the 5 over 3x?
This right here. So the same thing that that part right here, right?
Yeah.
The same thing that happened to the 8x in the first example. I factored this right here. I factored that. So maybe I'll just do that again. So it's always good to just, when you're not unsure about your factorization, if you factored correctly, just FOIL. So this is x minus 5 over 6 squared. So it'll be this times this. So we get x squared minus 5 over 6x, and then another 5 over 6x, and then negative 5 over 6 times negative 5 over 6, which this will be that 5 over 6 squared, right? And then we can combine these middle terms to get, what is it, 10 over 6x. And then we can, 10 and 6 have a common factor of 2, so we can cancel those out to get 5 over 3x. And that gives us this underlined term right here. So, any other questions about what happened here? So yeah, just make sure you're always, when you do the completing the square, it's going to factor very nicely. It's not like x minus something times x minus something else. It won't be like when you complete the square, you'll never get something like this. It's always going to be x minus something squared. It's going to factor very nicely. It's going to be a perfect square. These are called perfect squares. So that's why you don't that's where kind of where the middle term goes. Like it disappears in that way because you factored it. Is there any other questions about what's going on here, or maybe still is anyone still confused about that? Do you want me to go over that again? No? Okay. So are there just any questions at all about the homework, general questions about the homework or the quiz or anything else?
Can I ask a question on a specific question on one of the homeworks?
Yeah, we can. Is it due? Okay, is it which one homework?
The one due Saturday, 1.2.
Okay, let's see. Yeah, maybe I can do something like it. So can you? Actually, I can. Okay, hold on. Because all the problems, every student gets a different problem set. Do you know? So it's section 1.1. Do you know which problem it is? I think you're muted. Do you know, Greg? Do you know what problem it is?
Number 15.
Number 15. Okay, let me see. See if I can do something like it.
At least part A.
Okay. All right. I see. Yeah, that's good. All right. Yeah, we can do that. Before I go, let me just before I do this, we're if no one else has any questions, I'm just gonna take us. Let me see. I just need to take for attendance. I'm just gonna take this screenshot of everyone here. Oh wait, hold on. I did not want to do that. Let me take a screenshot of. I feel like there are more people here though. Okay. Okay. So I just took a screenshot. So if we're pretty much done. If you're free to leave if you want. But if you want to see me go over this problem, that's fine too. I just needed to take attendance of the people who are here. So let me just. Okay. All right. So let's go over this problem now. So part A you said, right? Let me see. So the problem is, or it's going to be close to it. It's going to be similar to it, is to simplify the following. So it's not going to be exactly like your problem, but it'll be similar.
Okay.
So the idea is, that if you have a to, you're taking the sum root of it, let's say like the nth root. This is the same as doing a to the 1 over n. This is just, these things are kind of just defined to be the same. So the idea is just to do that, apply this equation to both terms right here. So if you take, so in our case, a will be y to the 4th. So we're going to take a, which is y to the 4th, and we're going to take the 3rd root of it, like this. And then we're going to do the same thing here. We have y to the 7th, so this is our, now we're saying a is y to the 7th, and we're going to take the 1/5 root here. And then the way that power exponents powers work is that if you have a to some power, I don't know, p, and then you raise it to q, it's the same thing as multiplying the two powers. Like if you have an exponent to an exponent, it's just the same thing as taking the product of the exponents. So we're going to do that. We're going to just do that twice. So we have exponent of 4 and exponent of 1/3. So we 4 times 1/3. And then over here, we have exponent of 7 to the 1/5. So it'll be 7 times 1/5. And then we'll get y to the 4/3, and then y to the 7/5. And now at this point, we use the fact that if you have a to some power p, and then you multiply a some power q, you just add the powers, right? So now we're going to add these powers. So we have 4/3 plus 7/5. And I'm including probably more steps in than you need to. Like, you probably don't need to do this step here, really. But I just wanted to just illustrate. You can just go from here to here, and then here if you want, say. But I just want to include more steps so we understand exactly what's going on. So we need to find a common denominator now. And so we'll multiply this fraction right here by 5/5, and then this fraction by 3/3. So that will give us 20/15. And this will give us 21/15. And then we can add these together to get 41/15. That makes sense how to do that?
Yep. Thank
Cool.
you.
Yeah, no problem. Does anyone else have any other questions? No. All right. So yeah, we'll just head out now, and I'll upload this later. So I'll see you guys when I see you.
Have a good one, Professor.
Yeah. Take care.
Have a good one.
I have a question.